Welcome back to Data Science Pursuit. In previous videos, we mentioned that programming is an important skill for data scientists, and we gave you a quick definition. In this video, we'll go into more detail to explain what programming is and a few things beginners should know. Simply put, programming is a form of communication with the computer. So when I gave my sister this definition, she was not amused. Apparently, it seems oversimplified and it tells her absolutely nothing. And that's fair, that's fair. But in time, I hope she and you will understand why this is a good definition. For now, here's a more precise definition. Programming is the act of giving a computer commands or instructions for it to complete a task or solve a problem. These written commands are referred to as code, and the finished product is a program. Think about driving rules, for example, how to turn left or right at an intersection. These are logical, well thought out instructions on how to drive safely and efficiently. Self-driving cars can be programmed with these instructions to teach them the basics of driving. Let's dive into more examples in everyday life. The first example is a simple one, calculators. Calculators are programmed to allow the user to perform calculations. Then we have traffic lights. Modern traffic lights are programmed to manage traffic automatically. For example, they use sensors like cameras to infer how much traffic is around and control traffic lights accordingly. Then lastly, any applications, also referred to as apps, on your mobile phone or any electronic device are made using programming. So most of us have likely seen at least one product of programming, but since our channel is focused on data science, let's look at some examples for that. As mentioned before, because the world is becoming more digital and there's a vast amount of data available, programming is used at almost every step in the data science process. Firstly, programming can be used to extract data, for example, from websites, which is called web scraping. There's a lot of data available on the internet. Extracting that data can make a big impact on your project. Knowing web scraping has its advantages outside of work too. My former boss used web scraping and automation to buy a book that kept getting sold out. Programming can also be used when analyzing and cleaning data. Computers can help data scientists find patterns and issues quickly. And then there's my personal favorite, machine learning. As previously mentioned, machine learning models are in fact programs that can be used to identify insights and make predictions from data. They are an important tool in the data science tool belt. And lastly, programming can be used for automating and scheduling tasks. We schedule tasks and models to run automatically, which frees up time for us to focus on more current projects. I've used automation and scheduling outside of work. I was losing track of time, watching Netflix on my laptop. Setting alarms didn't work. I just kept hitting that snooze button. So I scheduled my laptop to restart when I needed to go to bed and continue to restart every 5 minutes. This was way more inconvenient than the alarm, and for a while it got me to bed on time. So I'm a semi-huge fan of this one too. To give computers instructions, we must be able to quote unquote speak their language. This is what a programming language is for. A programming language is a tool we can use to write commands to a computer. Like most written languages, it consists of symbols or characters and rules known as syntax. I like the use of the word language here. It's a reminder that programming is communication with the computer, even if it's just to get it to do something for us. There are different types of programming languages, low-level languages and high-level languages. Let's start with an example of a low-level language called machine language. Machine language is the only language machines or computers can directly understand and execute. It is a combination of zeros and ones, which is why it's sometimes referred to as binary. The zeros and ones are like switches to a computer. Ones represent on and zeros represent off. Each combination means something to the computer. For example, the binary code for the letter P is 0, 111, 00, 00. Now, if you want to write what is programming, this is what it will look like over here. Ooh, machine language is difficult for most people to understand, and any other language close to it are examples of low-level programming language. So before I scare you off, let's look at easier languages. So most programmers, at least in data science, use high-level programming languages. These languages are relatively easy to understand because the code looks like math and English-like words. Python and R are examples of high-level languages, and these are the most used programming languages for data science and statistical analysis. For example, if we wanted to write what is programming in Python or R, it would look like quote unquote what is programming, like on the screen right there. Pretty simple. We can all read that. I believe that coding, which is writing code, in Python and R is for everyone. It may be a bit harder for non-English speakers, but there are only a few words you need to know, and the most important thing is understanding the meaning of your code. So we mentioned that computers can only understand machine code. So you may be wondering how these languages are executed. Well, high-level languages use programs that are essentially translators to execute the code. One is called a compiler, which converts high-level code into low-level, generally machine code. The other is called an interpreter, which can execute high-level languages or an intermediate language called bytecode, line by line. For Python or R, the code is compiled to bytecode first, which is then read and executed by an interpreter line by line. So it would be irresponsible of us to send you off without letting you know the common errors you encounter. So the most common errors that programmers get are syntax errors and semantic errors. Let's start with syntax. Syntax means the rules that dictate the correct way to write code. These include the proper format or arrangement of characters and all the characters needed to form valid code. Each programming language has its own syntax. And computer syntax is like syntax in grammar, except for one crucial difference. If you use incorrect grammar, people may still understand what you're trying to say. But if you write code with incorrect programming syntax, a computer will have no idea what you're asking it to do. When you use incorrect syntax in programming, you get a syntax error. You may have seen a syntax error while using a calculator. The syntax for addition, for example, is a number plus another number. If you enter something like 1 plus into a calculator, the words syntax error will appear on your screen. If you enter a second number, then you have the correct syntax. This is the exact same thing that would happen if you typed that exact command, 1 plus, into a programming language. You likely get a lot of syntax errors, especially when you start coding. So please don't get discouraged because even experienced programmers get syntax errors. You can always search the internet for the syntax you need help remembering, and ChatGPT can be a helpful resource as well. The more you code too, the more syntax you will remember. All right, the next one is semantics. Semantics is what your commands or code mean, which is what your computer would do. We use the word commands in the definition of programming and in this definition as well to emphasize that computers will do exactly what you tell them to. A semantic error occurs when you give a computer the wrong instructions. This is usually due to incorrect logic or you missing something in your code. Your computer will not know that the instructions are incorrect, so you won't get an error message. The program will run, quote unquote, successfully, but the result will be incorrect or not what you were looking for. This makes semantic errors one of the most difficult ones to detect. An example of a semantic error is a program that is supposed to calculate the total cost of something, but the programmer forgets to add sales tax. Other examples could be as simple as adding when you're supposed to subtract or dividing when you're supposed to multiply. Since you won't get an error message, you must check that your results are what you were expecting. If not, go back and look at your logic and anything you may have missed in the code. Doing this step by step as you write your code is the least overwhelming way to detect and correct semantic errors. You encounter other errors as well, which will likely give you an error message, well, thankfully. My advice is to Google any error you get. The internet can likely help you figure it out. Some people believe that computers perform magic. On the contrary, people with more knowledge of how computers work would say that computers are, well, dumb. First of all, how rude. And secondly, what does this mean when they allow us to do such amazing things? Well, as the end users of programs, it makes sense that we believe computers can do anything. Just look at ChatGPT, for example. It's amazing. But as future programmers, we need to realize that someone instructed machines or computers to perform that tasks. What those programmers started with is nowhere near the level of sophistication of the end product. So keep the following in mind when learning to program. Number one, as mentioned before, computers will only do what you tell them to. Therefore, a programmer must be able to give good instructions. This involves logic, precision, creativity, and problem solving. The instructions also need to be detailed with no steps left out. So let me phrase this differently so it hopefully sticks. Computers will not give you what you want if your instructions are incomplete, incorrect, unordered, or missing any steps. So keep this in mind as you learn to program. And number two, computers have no common sense whatsoever. As mentioned previously, in machine learning, you teach machines using data. There's an expression, garbage in, garbage out. If that data is incorrect, the computer cannot tell you, even if it's an obvious error like a negative age or something like that. It will simply learn the wrong thing. So it's your job to make sure that the data is correct before teaching it to a computer. So even when we look at some applications or programs, we can see the limitations of computers, which is that they can only do what the programmer instructed them to do, nothing beyond that. So I drove to meet some friends one day using Google Maps. The fastest route was through the city park. When I got to the park entrance, the road was blocked for, I think it was a marathon or something like that. No matter what I tried, Google Maps gave me the same route that was blocked. I could not find the option to tell it that the road was inaccessible because it seems it wasn't programmed that way. I decided to manually find another route, and when I was far enough, it then recalculated. Google Maps is great, and I would still give it 5 stars. But this example is just to illustrate that computers are not magical. They will only do what their programmers have instructed them to do. In summary, computers are just tools to help you complete a task. How to get that task done correctly is the human's sole responsibility. As with a calculator, you must enter the correct expression to get what you want. So having unrealistic expectations of your computer can lead to disappointment or frustration. When learning to program, please pay attention to how computers work so you can better instruct or command them. Alright, so we've come to the end of our video, and as usual, let's look at some key takeaways. Programming is the act of communicating with the computer using programming languages. As a person learning programming, it is best to have no expectations of your computer. That way, you can learn programming with curiosity and an open mind. This is necessary to truly understand how computers work so that you can come up with effective instructions. So for now, we're done with theory, and we can start getting our hands dirty with programming, and you can choose which programming language you want to learn between R and Python. We'll provide courses for both. But first, we will summarize what we have learned so far in the next video. I'll see you then.